Hey, I'm Kyorash.
And I'm Himmel. It's like the Himalaya without the Aya.
And today we're going to talk about elastic collisions. So first we're going to explain what a collision is.
A collision is an isolated event between two moving objects that exert forces on each other.
There are two types of collisions, but today we will be talking about elastic collisions.
We're going to define what an elastic collision is and what it isn't. To make things as simple as possible, we are now two objects in one-dimensional space. An elastic collision is a collision in which both kinetic energy and momentum are conserved. This means that the two objects stay separate both before and after the collision. This happens by either the objects bouncing off each other or one staying in place after hitting the other.
This is different from an inelastic collision in which momentum is conserved but not kinetic energy. In this case, the two objects stick to each other. Hey Himmel, do you mind if I use the fridge real quick? I have to break down some collisions.
Yeah, sure, man. Here you go.
Wonderful. So the main two concepts to know for elastic and inelastic collisions are conservation of momentum and conservation of kinetic energy. Remember, the equation for momentum is P equal mv, where m is the mass of the object and v is the velocity of the object. For elastic collisions in one dimension, conservation of momentum applies. That means the sum of the momentums of the objects before the collision is the same as the sum of the momentums of the objects after the collision. We can write that as m1v1, the momentum of this first object before the collision, plus m2v2, the momentum of the second object before the collision, is equal to m1 v1 prime, which is the momentum of the first object after the collision, plus m2 v2 prime, which is the momentum of the second object after the collision. As you can see, the sum of the momentum before the collision is equal to the sum of the momentum after the collision.
All right, let's take a look at conservation of energy for elastic collisions. So remember that the equation for kinetic energy is 1/2 mv squared, where m is the mass of the object and v is the velocity of the object. So for elastic collisions, we can write this down as 1/2 m1 v1 squared, which is the kinetic energy of the first object before the collision, plus 1/2 m2 v2 squared, which is the kinetic energy of the second object before the collision, is equal to 1/2 m1 v1 prime squared plus 1/2 m2 v2 prime squared, where this is the kinetic energy of the first object after the collision, and this is the kinetic energy of the second object after the collision. So as we can see here, the sum of the kinetic energy before the collision is equal to the sum of the kinetic energy after the collision, meaning that the kinetic energy for the total system is conserved.
Hey, let's do some more examples in real life. Here we have two still disks. This would be our object 1 and this would be our object 2. As we can see here, object 1 stayed roughly in the same location as object 2 before the collision, and object 2 moved at roughly the same velocity as object 1 before the collision. Let's do it again. Okay, let's look at some more examples here. Here we have two marbles colliding into each other. The marbles bounce off each other at roughly equal and opposite velocities, signifying an elastic collision.
Let's take a look at one more example, this time with these two identical cars bouncing into each other. As you can see here, the velocities of the cars after the collision is significantly lower than the velocity before the collision. Let's look at that one more time. So this collision is something we're more likely to see in real life because no collision is truly elastic. This is because the kinetic energy of object 1 is never fully transferred as kinetic energy to the second object, as a lot of the energy is dissipated as heat, sound, or even deformation into the object. Elastic collisions are still important as they provide very good models
Collisions!
of what collisions should be under ideal conditions. My name is Himmel,
And this is Kiorash.
and this has been Elastic Collisions.